When we think of space exploration, we imagine cutting-edge technology. But here's a surprising fact. The way we navigate in space is surprisingly outdated. It's true. Some of the methods we use haven't changed much since the early days of spaceflight. We're talking about the 1960s, folks. This reliance on old technology poses serious challenges for our space ambitions. Imagine relying on a flip phone for all your communication and navigation. That's a bit like what it's like navigating in space. In this video, we're going to delve into the world of space navigation. We'll uncover why it lags behind and the implications for future space exploration. Get ready to have your mind blown as we explore the fascinating and often overlooked world of how we find our way in the vastness of space. It's a journey you won't want to miss. Space navigation is like GPS, but on a cosmic scale. It's how spacecraft figure out where they are, where they're going, and how to get there. Sounds simple, right? Well, in the vast emptiness of space, it's anything but. Accurate navigation is crucial for every aspect of space exploration. From launching a satellite into orbit to sending astronauts to Mars, getting lost is simply not an option. Imagine missing your exit on the highway, but instead of being a few miles off course, you end up millions of miles away from your target. That's the kind of risk we're dealing with in space. So why is space navigation so challenging, and why are we still using outdated methods? Let's unpack the reasons behind this surprising truth. Navigating in space is nothing like finding your way around town. There are no road signs, no landmarks, and no GPS. It's a completely different ballgame. The sheer vastness of space is a major challenge. Distances are almost impossible to comprehend. Precision is crucial in space navigation. Time delay complicates real-time control. Here's a sobering thought. Much of the technology we use for space navigation today was developed during the space race era. That's right, we're relying on systems that are over half a century old. While these systems have served us well, they're showing their age. They're often bulky, power-hungry, and not as accurate as we need them to be for more ambitious missions. Imagine using a 1960s computer to control a modern-day self-driving car. It just wouldn't cut it. This reliance on outdated technology poses significant risks to our space missions. A small navigation error can have catastrophic consequences, potentially leading to a mission failure, or even putting astronauts' lives in jeopardy. It's like setting sail across the ocean with a compass that's slightly off. You might end up miles away from your intended destination. Upgrading our space navigation systems is not just about improving efficiency, it's about ensuring the safety and success of future space exploration endeavors. Another major challenge with current space navigation methods is their lack of adaptability. Most spacecraft rely on pre-programmed trajectories, calculated before launch. This approach works well for predictable missions, but leaves little room for adjustments. If a spacecraft encounters unexpected obstacles, it's a major undertaking. We need to empower spacecraft with more autonomy for real-time decisions. Let's talk about how we actually navigate in space. One of the oldest and most reliable methods is celestial navigation. It's the same technique used by sailors for centuries, except instead of using a sextant to measure the angle of the sun or stars above the horizon, spacecraft use digital sensors and complex algorithms. By comparing the positions of known stars and planets to their onboard star catalogs, spacecraft can determine their orientation and position in space. It's like having a cosmic map etched into the fabric of the universe itself. However, celestial navigation has its limitations. It requires precise measurements and can be affected by factors like starlight being bent by the gravity of massive objects in space, a phenomenon known as gravitational lensing. While celestial navigation is still used today as a backup system, it's not accurate or fast enough for the demands of modern space travel, especially as we venture farther into deep space. Another common method is ground-based tracking, which relies on a network of antennas on Earth to communicate with and track spacecraft. Think of it like a giant game of cosmic Marco Polo where ground stations send radio signals to a spacecraft, and the spacecraft responds back. By measuring the time it takes for these signals to travel back and forth, we can determine a spacecraft's distance, speed, and trajectory. This method works well for spacecraft in Earth's orbit or relatively close to home. However, as we send missions farther out into the solar system, the signals become weaker, and the time delay increases, making real-time control and communication increasingly difficult. It's like trying to have a conversation with someone on the other side of the world with a long delay between each sentence. Communication becomes choppy and inefficient. We need more sophisticated methods for deep space exploration. Both celestial navigation and ground-based tracking have served us well, but they are becoming increasingly inadequate for our future space ambitions. These traditional methods are like trying to navigate a bustling city with an outdated map and a compass. It might get you there eventually, but it's not the most efficient or reliable way. As we set our sights on more ambitious missions like sending humans to Mars and beyond, we need more advanced navigation systems that are more accurate, autonomous, and adaptable to the challenges of deep space. Imagine a spacecraft that can navigate autonomously, making real-time decisions based on its surroundings, just like a seasoned explorer would. That's the kind of innovation we need to push the boundaries of space exploration and unlock the secrets of the cosmos. Scientists and engineers are developing revolutionary technologies to transform space navigation. Autonomous navigation aims to give spacecraft the ability to navigate independently. Imagine a spacecraft with advanced sensors, AI algorithms, and powerful processors. This would enable us to explore the cosmos with greater flexibility and efficiency. It's like giving a spacecraft its own brain, reacting to unforeseen circumstances. Autonomous navigation holds the key to unlocking new frontiers in space exploration. Pulsars are rapidly spinning neutron stars, the dense remnants of massive stars that exploded as supernovas. These cosmic lighthouses emit beams of radio waves from their magnetic poles. As they spin, these beams sweep across space like a lighthouse. We detect these beams as pulses of radio waves, hence the name pulsar. Some pulsars spin hundreds of times per second with incredible precision. This regularity makes pulsars ideal for space navigation. Pulsar navigation relies on a method called pulsar timing. Essentially, a spacecraft would use a specialized instrument called an X-ray timing instrument, or XTI, to detect the arrival times of pulses from multiple pulsars. By comparing these arrival times to a pre-programmed catalog of known pulsar positions and pulse periods, the spacecraft can calculate its position in space. Think of it like this. Imagine you have 3 friends standing in a field, each with a drum. You're blindfolded, but you know where your friends are standing and how fast each one is drumming. By listening to the drum beats and timing how long it takes for each beat to reach you, you could figure out your own location in the field. Pulsar navigation works in a similar way, using the incredibly precise drum beats of pulsars to pinpoint a spacecraft's location in the vastness of space. Pulsar navigation offers several key advantages over traditional methods. First and foremost is its incredible accuracy. By utilizing the precise timing of pulsar signals, spacecraft could determine their position with an accuracy of a few kilometers, even in deep space, far beyond the reach of our ground-based tracking networks. This level of precision is crucial for navigating through complex environments like asteroid belts or for landing safely on other planets. Secondly, pulsar navigation is autonomous. Spacecraft equipped with pulsar navigation systems wouldn't need to rely on constant communication with Earth for guidance. They could independently navigate their way through the cosmos, making real-time decisions based on their surroundings and mission objectives. This autonomy would significantly reduce the workload on ground control and pave the way for more ambitious and distant space missions. While pulsar navigation might sound like something out of science fiction, it's rapidly becoming a reality. Space agencies around the world, including NASA and the European Space Agency or ESA, are actively researching and developing pulsar navigation technologies. In fact, NASA has already tested the concept on the International Space Station, or ISS, with promising results, demonstrating that pulsar navigation is not just a theoretical possibility, but a viable technology for the future of space exploration. The development of smaller, more sensitive and space-worthy X-ray detectors is crucial for making pulsar navigation a standard feature on future spacecraft. As technology continues to advance, we can expect to see pulsar navigation playing an increasingly important role in deep space missions, enabling us to explore the cosmos with unprecedented precision and autonomy. The adoption of pulsar navigation represents a paradigm shift in space exploration. It has the potential to revolutionize the way we navigate in space, opening up a new era of exploration and discovery. Imagine robotic missions autonomously navigating to the outer reaches of our solar system, mapping the surfaces of distant moons, and even searching for signs of life on exoplanets, all without the need for constant human intervention. Pulsar navigation has the potential to make these ambitious missions a reality, transforming our understanding of the cosmos and our place within it. As we venture farther into the great unknown, pulsar navigation will be our guide, a testament to human ingenuity and our relentless pursuit of knowledge beyond the confines of our pale blue dot. As we've seen, space navigation is at a crossroads. The methods that have served us well for decades are rapidly approaching their limits. Relying on outdated systems and rigid trajectories is like using a horse and buggy in the age of high-speed trains. It's simply not sustainable for the future we envision in space. We need bold innovation to keep pace with our ambitions. We can't expect to unravel the mysteries of the universe with tools from a bygone era. The challenges of deep space navigation, with its vast distances, signal delays, and unpredictable environments, demand a new approach. We need navigation systems that are more accurate, more autonomous, and more adaptable than anything we've ever created. Just as GPS revolutionized travel on Earth, we need a similar revolution in space navigation to unlock the true potential of space exploration. The future of space exploration hinges on our ability to develop and implement these groundbreaking technologies. The good news is that we're on the cusp of a new era in space navigation. With technologies like pulsar navigation on the horizon, we're moving towards a future where spacecraft can chart their own course through the cosmos, making real-time decisions and adapting to unforeseen challenges with minimal human intervention. This paradigm shift will empower us to explore the universe in ways we can only dream of today. Imagine sending probes to study the atmospheres of gas giants, land rovers on the icy moons of Saturn, or even dispatching robotic miners to extract resources from asteroids, all with a level of autonomy and precision that was once unimaginable. These are not just pipe dreams. They are the tangible outcomes of investing in advanced space navigation technologies. By pushing the boundaries of what's possible, we're not just advancing our understanding of the universe, we're inspiring future generations to reach for the stars. The journey into the cosmos is a shared human endeavor, and that includes you. Space exploration isn't just about rockets and robots, it's about expanding our knowledge, pushing the limits of our technology, and inspiring future generations to dream big. What are your thoughts on these incredible breakthroughs in space navigation? What new frontiers would you like to see us explore with these advanced technologies? Share your thoughts and ideas in the comments section below. Let's ignite a conversation about the future of space exploration. Your curiosity and passion are the fuel that drives us to explore the cosmos and unravel its mysteries. As we conclude our exploration of space navigation, a new chapter in space exploration is beginning. Groundbreaking technologies like pulsar navigation promise unprecedented accuracy and autonomy. Imagine robotic missions venturing to the far reaches of our solar system, gathering data with minimal human intervention. Robotic miners extracting resources from asteroids, all guided by cosmic lighthouses. These are tangible possibilities as we push the boundaries of space navigation. Thank you for joining me on this incredible journey through the world of space navigation. I hope this video has sparked your curiosity and inspired you to learn more about the incredible challenges and possibilities that lie ahead as we continue to explore the cosmos. Remember, space exploration is not just for astronauts and scientists, it's a shared human endeavor that belongs to all of us. Your questions, your curiosity, and your support are what drive us to reach for the stars. So please, share your thoughts on these new breakthroughs in the comments section below. What excites you most about the future of space navigation? What mysteries of the universe do you hope will unravel next? Let's keep the conversation going. And as always, thank you for watching Time Pilgrimage, and please remember to subscribe and like. If there is a topic that you would like to explore, please drop a comment.